The final part of Unit 3 has to do with heat capacity. Heat capacity is a topic that we talked about, and actually we used it in a number of ways, whether you realized it or not. But we watched a video, we did a lab, and we talked about specific heat capacity, which is indicated with a little c. But this, by definition, is the by definition, let's write this in here. It's the energy required to raise the temperature of 1 gram of any substance by 1 degree Celsius. Within this unit, we talked about the difference between the heat capacity of water and land. We, within the lab, talked about the different heat capacities that you see when you work with various metals, and you guys did that. You shared data. But what we see here, even within the quantitative Q calculations, is that solid ice and water have different heat capacities. And so on the next slide, we'll discuss this. Solid water has a heat capacity of 2.1 joules per grams degree Celsius. Liquid water has a heat capacity of 4.18 joules per gram degree Celsius. And what this is saying is that it only takes about half as much energy to raise the temperature of ice, 1 gram of ice, by 1 degree than it does liquid water. So metals have low heat capacity, and when you guys set up the lab and you put your piece of metal into a beaker of water, what you saw was the heat from the metal was transferred into the water, and your initial temperature of the water could have been around 22 degrees Celsius. But after you place the metal in, and over time collected data, the temperature of the water actually may have gone to 22.5. Now again, I'm making that up, and you'd have to go back in your lab. But we saw an increase in the temperature of the water, whereas over time the initial temperature of the metal was probably right around 100, and the final temperature of the water of the metal, you could basically reach right into the beaker of water and pick it up. So it ended up being the same temperature as the water. So there was a very large decrease in the temperature of the metal. So the energy was flowing from the metal into the surroundings, which was the water. So the metal cooled down and the water heated up. So this whole unit was about energy exchange, and what's happening at the particle level.